Today, we're going to be looking at the strengths of acids and bases. And essentially, when you're comparing conjugate acid base pairs, the one that ionizes the most is the one that is the strongest. And let me kind of explain what I mean. So let's consider a conjugate acid base pair. So we have, for instance, hydrofluoric acid and fluoride. Well, if you put them into water, for instance, HF reacts with water to make H3O plus and F minus. This is your acid and its conjugate base. All right. Now, this establishes what is considered to be an equilibrium position. And so essentially, if this goes a long ways towards the product side, then the acid is stronger than the conjugate base. On the other hand, if this reaction lies a lot towards the reactant side, then it would kind of imply that fluoride is the stronger base. This is a concept that we will talk a lot more about in detail when we get into our acid and base unit. But essentially, the stronger an acid is, the weaker its conjugate base is. And strong acids and bases ionize 100%. So a strong acid, for instance, when you put it into water, it goes 100% into H3O pluses and Cl minuses. And water is just kind of there to facilitate this. Essentially, strong acids, as soon as you put them into water, they break up with their hydrogen ion. And a strong base would also react 100% to produce hydroxides in solution or to accept protons. The thing about this is the pH of a strong acid or a strong base can be directly calculated from its molarity. We'll talk more about that once again when we get into our unit on acids and bases. For instance, if this was a 0.5 molar hydrochloric acid solution, then you're going to have 0.5 molar H3O plus. And as you'll see, pH equals a negative log of your H3O plus concentration, which would be the negative log of 0.5. And that would be how you would calculate the pH of this because it goes 100%. On the other hand, a weak acid like, say, HF, it goes maybe 1 to 2% into H3O pluses and F minuses. In case you're wondering, there are a list of some strong acids that you will ultimately need to familiarize yourself with. You've got hydrochloric acid, you've got hydrobromic acid, you've got hydroiodic acid, you have nitric acid, you have perchloric acid, and you have sulfuric acid. So those are all the strong acids. And if you're looking for your strong bases, that's going to be your group 1 and group 2 hydroxides, generally speaking. So like sodium hydroxide, barium hydroxide. We'll talk once again more about those when we get into our unit on acids and bases, but those are the ones that ionize 100%. And if you react a strong acid and a strong base together, the net ionic equation is that an H plus or hydrogen ion reacts with a hydroxide ion to make water. Right? So yeah, this is our list of strong acids and bases. Your group 1 and group 2 hydroxides. So it'd be anything in group 1 or group 2, keep in mind, excluding hydrogen. And then there's an asterisk beside H2SO4 because H2SO4, it will ionize to lose the first hydrogen 100%. So essentially goes H2SO4 makes H pluses plus HSO4 minus. But HSO4 minus is a weak acid in and of itself that can also lose a second hydrogen ion. So sulfuric acid is a weird one, and once again, we'll talk more about that in the next when we get to our acid base unit. The key thing to keep in mind about acid base reactions for the purpose of this context is if you have hydrogen ions moving around, it's an acid base reaction.